Hello everyone, and welcome to the webinar on leading intelligent engineering with Professor Frank Piller, award-winning Professor of Technology and Innovation. I'd like to welcome you to please post your questions throughout the webinar, and Frank will be able to address them around 10 minutes towards the end of it. And other than that, I'll let Frank take over and proceed.
Yeah, thank you very much, Carolina. Hello everyone, it's my pleasure to spend the next 45 minutes with you and share a little bit our, I would say, sometimes vision but also experiences about what we call intelligent engineering. Carolina already briefly introduced me. Perhaps one more word: I'm Professor for Technology and Innovation Management at RWTH Aachen University, with the, well, I think, leading engineering school in Germany. And my interest has been always around new trends and developments in the innovation function. But recently we looked a lot into business model innovation and corporate change because of digitalization, and not so much on consumer apps or Facebook sites, but more with regard to industrial large-scale applications. And this is exactly what we want to explore together also in this webinar. Next to my activities as a professor and head of an institute here at the university, always used to be in, or still are, lots of engagement with smaller companies and startups. So I think we all know that really this digitalization, connectivity, like IoT, Internet of Things, and big connected data have changed manufacturing and marketing function. In manufacturing, we talk about Industry 4.0, predictive maintenance, and a lot of predictions and prescriptive functions. But the question we asked ourselves about 2 years ago in a new research program was, well, but what is about research and development in the engineering function? So we also expect fundamental changes there. And that's exactly what we want to explore together in this webinar. The webinar builds on a new masterclass we have with the Leadership Network called Intelligent Engineering, which we now did 2 times with Volvo. So what I will present now was also some discussed and vetted with about 50 really heads of R&D departments, CTOs of larger companies, and we'll continue these seminars in the next year. And it also builds, of course, on the experience of a long-standing and very successful masterclass on the smart factory of the future. And this also will continue next time and next year. And so my challenge is now to provide for the left masterclass, to provide all the content what we normally need, to do in 3 days, to do it in 40 minutes. But I'll try to do my best. So we here have a kind of basic new product development process, and whatever you produce, is it a service, a big hardware product, is it a software product, you more or less follow the same processes and stages of really first trying to identify opportunities at the front end of innovation, then you transfer it with an ideation and a concept, and normally you have a big steering committee selecting a concept that you then put into design and development, and then you have the launch stage. And across this process, we had different understandings how to do these different stages more efficiently. So one big stream, and normally we do it in a kind of stage scale logic. So one big stream of research and also practice in the last good decade or so was open innovation. We really said, well, if we want to do successful R&D in engineering, we don't do it alone in our lab. We really integrate external partners, employees, customers, suppliers, research institutes. And I think many of you know about this. But then something others happened, and we realized there are also new kind of sources, and they are more unstructured sources. And this is what has been called data-driven innovation, or I tend to call it nowadays predictive innovation, meaning we realize we now have the ability to really look into data sources like not just a few scientific publications we found via a partnership of a research with a university research affiliation. No, we can have ability to scan millions of data documents, corporate publications, social networks. And just to give you an example that there's a lot of innovation in these unstructured sources, a simple but highly successful example, and this is really how also this webinar partly was promoted, how to find a €1 billion opportunity in unstructured social media data. And this is exactly what is happening today. You all in your companies, in society, at university, even in the political system, we talk about the huge opportunities of artificial intelligence and machine learning today. And we'll sometimes connect it to the fact that we have higher processing power to run these algorithms. But the real core trend behind is that we have lots of connected data, that we really have access to silos of data that were not accessible before, and we can make connections between those. And so we can do this since a lot of time, and the principle I now share in this case study can be replicated nowadays much, much more efficiently. And the case is about Beiersdorf, the manufacturer of Nivea. Probably know it, one of the most famous consumer brands on earth, I would say. But actually, one of the big categories of Beiersdorf or Nivea is not just body cream, but deodorant. And now think about, you are the category manager for Beiersdorf and you have to innovate the next version of the deodorant. And more or less, this is a very mature product. And what's your really solution space for innovation here? You tried it all, but whenever you come up, at one point, the price point kicks in that you really have to charge it. Otherwise, you will have no success in large scale. And traditionally, well, we would say, let's ask the market research people, and the market research people will go out and they will give you pictures like that. And if you look on this, say, oh yeah, I could have not that. People don't want no odor, want to smell good, they don't want to sweat, they don't want residues. There may be other things, but stop. Here at this point, we have to stop, as then our price point kicks in. However, we were in a project with Beiersdorf, and we said, how can we really find out what people talk about deodorant if we don't ask them in a market research setting? And the idea was really to learn what people are really saying or thinking about. And where do you find it? Well, perhaps on blogs and forums and social media. So really to look into this vast amount of people, and not just some selected people we invite in a focus group, but really everyone. Well, and I never would have thought this. I said, who the heck, why should people talk on the internet about deodorant, you know? But they do. All these black lines here are websites where people really talk about deodorant. And these are not always normal people. Well, they're all normal people, obviously, but they are not average consumers. They are perhaps consumers with specific needs. And they are not dedicated deodorant websites, but they are beauty websites, on sport websites, on fashion forums, and so on. And when we really looked into these conversations of consumers, we found, what are they actually talking about? And it was nothing what we saw on the pyramid before, but they all talked about this problem. Residues, you know, of the deodorant on white or black fabric. And they really cared about it. We found thousands of comments like this, what people really not just complaining about it, but what they really try to get rid of, these stains coming from the deodorant. Here, like with a hair blower, someone said, here she's creating her own very special washing powder to get rid of this, and so on and so on. And when really looking into these comments compared to other comments, we really thought this was a big open market opportunity. We actually found 90 self-made recipes of consumers for self-made deodorants against stains. And again, who would make their own deodorant? Well, professional dancers that are in a ballet, that have wonderful costumes, that really do sports in the costumes, and they can't bring them to dry cleaning every day, but they also want to use deodorant. People in other sports communities, but also very fashionable managers that like tight white shirts and, have to care perhaps of the dry cleaning by themselves. And they got annoyed that their nice white shirts got diluted by the deodorant. And what we found from really looking into these consumer forums, that consumers looked on that very differently. No odor, no sweating, no skin, no stains, were really on the same level. And there were also other consumer attributes not covered by market research before. And with this insight, then BDF, Beiersdorf, the company behind Nivea, they went out and really said, well, let's co-create with different suppliers, especially with fabric experts, and create a new product that really takes care of this. And the product is Nivea Invisible, or Nivea Black and White, how it's also called in some other markets. And actually, it was the most successful product introduction in the history of the brand Nivea. And also, of course, the most successful launch in the entire deodorant market after 12 months. It's something not coming out of the lab, but in the end, it was copied from consumers in France. And when we did this project several years ago, we actually had to read all the user postings. So a lot of interns. But today, we have wonderful algorithms that are doing this job. And so perhaps, and this is just one starting point, how we can look how digitalization is changing the R&D function. So perhaps we really have lots of really opportunities to find different kind of insights, and also in a rather efficient way. And that's exactly what we want to explore, so that there are these unstructured sources that really help us to de-risk the innovation process or make it more effective. The picture is not finalized. We'll come back to it at the end of this lecture. So what I want to introduce now is our framework to really discuss, or perhaps also strategize in your company, how digitalization, big data, and AI ML will change and empower the research and development or engineering function. So we have here our innovation process as a base. And below this, we have the so-called digital twin or digital shadow. If you know something about Industry 4.0, so digitalization and manufacturing, you should be familiar with these terms. They're really coming up very quickly. I will explain it, however, in a second. And often you find them in modern kind of PLM systems or life cycle management systems in your company. So what's this digital twin or digital shadow? But before I explain this, it makes sense to really see how the engineering function developed. So engineering somehow 1.0, if you are a little bit older, you'll learn this still in school or in university. To engineer something means to think about something, to represent it, to do trial and error. And it means to have some representation. And these used to be manual draftings. And then around CAD came on the market, computer-aided design, and this really made the entire design process much more efficient, as now you could reuse designs with modular databases and so on. And somewhere at the end of the last century, we realized, well, it would be nice not just to have it in 2D, but also in 3D. And once you have 3D CAD models, you also said, well, now I have a much better representation of the product I'm going to design. And with this simulation came up, but with all the data, also the need for new function, product data management, which is now a big function in large companies, to really take care of all these physical representations. However, what we had up to here was, so to say, an as-is engineering model. But once we really brought it into realization, often what actually has been produced and what actually how the product is changing once it's in the usage cycle with a user and a customer, it's different. And that's exactly the big idea of the digital twin. The idea is that now this CAD data is complemented by rich usage data. And where's this data coming from? Well, very often from the fact that lots of products, and especially industrial assets, are turning into so-called cyber-physical systems. So that somehow the traditional physical object has sensor information, is collecting, generating data, collecting and transmitting data, which often is stored in a cloud, in a higher level service, and where we have so-called algorithms or apps that make sense out of it and bring it into new services. And I think most of you are familiar with this kind of thinking. So, and we'll have the digital twin of the product. And traditionally, that was my CAD simulation model. But perhaps we now also have the ability to update it really to the exact specification. We now have almost a digital twin of the production. And this is just starting to be implemented. It really can enhance the digital product twin by the exact characteristics, perhaps, of the material used for the production of this particular product, the conditions of the machinery, perhaps even the temperature of our factory hall at this particular time. This all may influence the performance properties and the quality of the product. And then we have a digital twin of the performance, meaning of the usage of the product, if the product has sensors or is part of a system with sensors that also provides its feedback how the product is used, where perhaps there are cracks and so on. And with this, we come to engineering 4.0, and so really think about how can we leverage and design all these data around this virtual digital twin. But also, for me, we have now digital twins of customers. Think back of my example I gave you before. So these rich conversations in social media, we can see them somehow as a digital representation of consumer minds. And we can combine this and make connections. One very important differentiation perhaps at this point, and this is where here in Aachen we really care about a lot, and that's a differentiation between the digital shadow and the digital twin. And for me, this example of Google Maps was very helpful to understand what's happening here. Think about Google Maps, and the Google Maps is a simulation of the reality in form of a map. And the good thing with Google Map is that it's much more precise as a paper-based map, as it's much easier to be updated. But then Google Map has what might be really useful, this live traffic information showing you the utilization of the road system. However, for this, in Germany, for example, Vodafone is gathering every 5 minutes the location data of the cell phones to Google to really calculate the movements on the streets. As we realize, we don't need to do this in real time. It would be so much data no one would process. And so we get a digital shadow of the utilization of the infrastructure. And with this, now we get all the interesting new applications. And they are somehow this new kind of digital twin. So like Google Map with predictive traffic information, Google Map with dynamic suggestion for alternative routings. Google even can give you alternative means of transportation, or Google can give you suggestions where to build the new highway, and they probably know it much better than the local city authority. So you see the difference? We'll try to get of the infrastructure of the asset in as realistic virtual replication, the digital twin, as possible. However, on the usage data, we will reduce it to what we really can process, the digital shadow. And actually, this industry is a good example, as they also tell us that in the end, we still need humans. As there's another traffic app, Waze, now, of course, also owned by Google. And they enhance the digital shadow coming from connected cars and connected cell phones. They enhance this with input coming from real human beings, like a pothole, a speed trap, and so on. And this picture may show it a little bit how it looks on an industry setting. So we have on the lower end all the assets that produce data. And on the middle end, where here you see raw data, we have somehow the digital twin, a replication of lots of data. However, to make really decisions, either in the development, in production and usage, we can't use all this data. So big task actually is to reduce this data to something we can put into an analytical model. That would be the digital shadow. So we could talk much more about it, but don't have the time. So how is this data pool changing the development and engineering function? But this is why I explained the previous things. I think it's important to really acknowledge we have a very, very different data pool, or we are starting to build this data pool. And we often look at this data pool and we get first much better understanding how to do a data pool that's useful for manufacturing and operational efficiency. But how about research and development and engineering? So what happened in the engineering function was that along this development of these engineering paradigms, from manual drafting to using rich CAD data, also this understanding of the scientific process changed. In the past, and this is how we do really a lot of research and development in our companies, we have empirical observation and experimentation. You say, what's research and development? Systematic trial and error. And we observe, we set up a hypothesis, we set up an experiment, and we test it. Well, and this works, but has its limitations. So Einstein was perfect in showing us that many years, decades before we could empirically test it, he was able to come up with a theoretical thought model, about really fundamental laws of physics, that only decades later we had the measurement equipment to actually prove it. So next to this empirical observation and experimentation, we always had theoretical thought models as a piece of science. This combined was somehow where we often are today. We use complex computer simulations and modeling to really capture a large-scale real system to somehow investigate these thought models, in a much quicker and more efficient way compared to the traditional, hardware physical experiments. And this is very much still the state of the art. But there was one thought by Gray, a researcher at Microsoft Research, and he suggested something like Science 4.0, and that's actually the scientific process is changing. And he calls this a fourth paradigm, and actually if you Google this term, you find a nice free book for download that explains it more. But he says, let's assume that now we have so much data online. We can share this data, but there's already so much data online. And the scientific process may change. Instead of really, setting up a hypothesis and doing an experiment, let's use data analytics and look into these data, what we find. So the experiment is the experimental setting is the real world. And instead of formulating hypotheses, we do pattern recognition. And then we'll find a pattern that somehow is influential. And then we may theorize back and say, well, what's the reason behind? And this scientific process is somehow, and we'll know, not the end, and it's just complementing the other science approaches, but it's one of the thoughts where we already get a glimpse already that perhaps something is changing here. So in our model, we found 4 areas structured along the new product or service development process where AI, machine learning, and digitalization per se is changing the research and development function. And the first we call it predictive innovation with regard to really analyzing big data for opportunity recognition, both market and technological opportunities. We then can use the ability we also have nowadays to collaborative in the concept in ideation stage. We'll come to some of the core of this, that we say perhaps we now have algorithms that come up with new designs, so really generative algorithms that replace a human designer and have a very different design approach to technical problem solving. And then finally, if we produce connected products, we also really have to think how smart product ecosystems change this. So let's go briefly with a few case studies in all these 4 areas. And all of them are based on these digital twin and shadow, which is somehow needs to be represented. And the best term I could come up is like a modern-based product lifecycle management, PLM system for that. So Within predictive innovation, as I said, we can have data-driven market intelligence, technology scouting, and optimization. This is as Jessie said. She is an MIT graduate, and she founded a fashion company called Choosy. And the interesting thing is, as it says, they're fashion powered by you. But it's not a co-creation platform, where people go to the website and co-create fashion. No, she developed an algorithm, and the algorithm is automatically analyzing Instagram pictures and is somehow the algorithm is realizing what is really trending on Instagram. And then the algorithm, or another algorithm, is transferring these insights into fashion products. So she writes algorithms for fashions that were trending online to identify it, and then really she even creates the new fashion designs, and then she uses Industry 4.0 technology to really get a small batch out from a Chinese factory within less than 2 weeks. And these small batches are then sold to the people that really, according to their Instagram profile, probably would like them. And if they really like them and trend it back, well, then she has a proven assortment she then can sell in larger quantities to other manufacturers or brands. So a very different approach to come up with a fashion product. And what's happening here, so what are these AI machine learning based predictions and prescriptions is what is happening here. And here we have to differentiate that when we talk about digitalization, we really mean that, I would say, for me, the best term is what's happening is connectivity. And based on this connectivity, we get these big data sources. And then we have artificial intelligence as a means to explore and automate, the exploitation of these data sources in making recommendations, prescriptions out of this. And in the marketing or consumer insights field, quite a lot is happening. And what you see here, you should read it, but these are 2 landmark articles that really provide algorithms to automatically analyze customer reviews. You now know on every hotel website, on Amazon, in every web page, we have tons of customer reviews. And we can automatically analyze these reviews, perhaps for risk management. But the white paper here describes a very nice algorithm to automatically identify product features that really drive positive reviews. So you can purposefully design your product in a way that you get favorable reviews, and hopefully favorable reviews are connected to higher customer satisfaction coming from better fitting products. And actually a great source, and this is where we did quite some research on this, is crowdfunding. Sites like Kickstarter and so on. And there you have hundreds of thousands of really products, concepts that are connected, that are compared, that are pitched, where people provide input here. Just a simple example from a work with Hive, a company where I serve on the board in that field. And so take bike helmets. And there are dozens of bike helmet projects on Kickstarter. And some on the left-hand side, they worked well, some did not work well. On the first, they look all the same. And of course, you could read it all, but you also can have an algorithm that automatically trends all, scouts and analyzes all pitches, project pitches in your category, and tries to understand what are really the characteristics of successful campaigns versus those that fail. So very rich, novel kind of data. And we actually wrote an algorithm where the algorithm can watch the videos, which are an important element. So we have an algorithm that can analyze the video, and not just the speech in the video, but also the image, how they are proposed, to find specific innovative users that may be helpful as they are leading edge users in our category, to really then perhaps invite and learn them to our company and work with them. So there we really have had in the last years big advancements. Of course, this also works for technology scouting. Citroën Informatics is a company that got quite some funding, and they really have AI-powered materials informatics. So they really have a machine learning platform that mines vast quantity of data about new materials and new production processes for materials to really help you to make better decisions in discovering new materials, discover alternatives for materials, and so on. So, and before we started this research stream, I thought there's more in the technology scouting field, but I learned it's a field that's just evolving. However, in the field of patent research, IP, we really have this. And this picture shows quite good what is new. In the past, if you, let's say, you want to file a patent and you have to do freedom to operate analysis to find prior art. And in finding prior art, traditionally you did a Boolean text search. So you only could find the documents, for which you had your the search terms. Then the state of the art nowadays, semantic search, as we have different kind of, libraries of words and so on to have a much richer search. But with the idea of an artificial intelligence search is, to explain it very, very briefly, that you really can find connections between patterns and structural models of data for what you never thought of, and for what you didn't was actively searching for, and for what you also did not document in a synonymous database. And sites like Ambersite and so on are there, startups, to really help you to find patents, prior art in different ways. So that's a field that's rather more developed. So this first pillar of predictive innovation is really about finding innovative patterns and connected sources of big data using advanced analytics with AI ML. The next is a collaborative front end. I do it very, very quickly, as the idea here is that not so much we use big data analytics, but we use the ability of online platforms to connect different owners of knowledge, different actors. And with the terms crowdsourcing and co-creation, this has been done in the consumer field. But I just want to focus here on open innovation platforms, as just think about what is really innovation, as an activity. Well, it's disciplined problem solving. What do you need to solve a problem, a technical problem? Well, 2 ingredients. First, you search. And search is based on your prior experience. You search for prior art, and based on the prior art you find, you will set up an experiment to do trial and error learning. So to do this, you need knowledge and creativity, the 2 core ingredients for the innovation process. However, we know when some of my discipline of innovation management originated in that problem, we know that we are biased by local search, meaning both in the way where we search for prior art, in the way how we set up our experiments are biased by the past, by our experience. We have past dependencies. And you very often know as a practitioner if a product, if a project does not meet your time and cost to market requirements, it's often as you just don't get it done. You can't find the right knowledge. And of course, we have a lot of practices like water cooler talks and diverse interdisciplinary teams and so on to overcome that problem. However, another idea is that we have marketplaces. Marketplaces here like Experfy that really help you to find in that case algorithms for all kind of business applications. Or we have these open innovation platforms that use crowdsourcing for technical challenges, where instead of that you seek for a solution, you as a seeker broadcast your problem to a large network of solvers. And then these solvers screen your problems and submit in an often contest situation a solution proposal. And I'll come back to this slide, but this is a good example of how this worked. So this here, the last one, was for a German OEM, an automotive manufacturer. And in these fancy cars nowadays, you have a motor that is closing the doors. And in my cheap car, if I have my finger in the door and I close it, it's my fault. But in a fancy car, if I have my finger in the door and the car motor is closing the door, I can sue the manufacturer of the car for hurting my finger. So this OEM was in the need of a finger sensor, and he couldn't find one with his usual suppliers. And then they put up a call on a platform. Here, this is the example of 9 Sigma, but there's Innocentive yet 2 and 80 other open innovation platforms. So you say, I really look for a sensor with these characteristics, has to work under these requirements, cost target is this. This problem was sent out to 10,000 of potential solution providers. Perhaps 20 submitted a solution, and the winning one was coming from a sensor manufacturing from Denmark for the agriculture industry, who had a wonderful sensor to place a milking robot at the udder of the cow. As no idea how you call this in English, but these parts of the udder, well, they're like a finger, and these manufacturers of sensors for the agriculture industry never thought that someone in the big German automotive industry would be interested in the sensor, and actually the other way around not. No one in the German automotive industry would have looked into the agricultural industry of milking robots for cows, that they had a solution, an existing solution for their problems. So it's about making unobvious connections. And this is one of the big drivers of digitalization, that we really have lots of tools to make these connections much more efficient and effective. So this is my definition of open innovation, to really connect unobvious others, and the existing concept and technologies of unobvious others with your company as an input for the innovation process. And that's exactly the idea of the collaborative front end as a second pillar. The third pillar is digital AI design and engineering. And I have to admit, this is not so much the core of my expertise. I'm more in the 3 other pillars. And the class with the leadership network that we do, this part is taught by Tim Simpson, a very, very well-respected colleague from Penn State University in the United States. So Tim could explain it much, much better to you, but I will try to do my best. As where we really see the generative design algorithms, different kind of simulation techniques, and also robotic experimentation is changing the engineering function. And think about, technologies really have enhanced the experimentation capacities of companies since long. So we have simulations instead of really building physical prototypes. We have virtual prototypes, and we can really simulate a lot now, like with finite parts analysis. 3D CAD, we have augmented reality that really helps us to see prototypes now in reality. In especially the pharmaceutical industries, they came up with robotic experimentation to really allow high throughput screening. And actually, you only could make sense out of all the experimental outcomes by machine learning to really analyze the results of these physical experimentations. And of course, we have rapid prototyping, tooling, 3D printing also as this. So lots of these technologies are rather old, and they're very helpful, but they're not that what we mean about digitalization. That was more the past, but we have algorithms. As behind these technologies, we still had human developers that came up with a new design. And then they used rapid prototype to make a prototype to test it. You created a model and you tested it in augmented reality and so on. But there are algorithms that really come up with the design. So there's one example from the aerospace industry. We really have algorithms which you train how to design components of an airplane. I'll show you an example in a second. And they come up with a better design. And we have one example in our class last time. We had the founder of Borgers, a Dutch-based, really cool company, and they do it more in the consumer good market. And they have a site, and that's a roadmap. It's much too complicated here, but they really trained algorithms to understand what a cup is, what a teapot is. And you just can give the algorithm as a consumer a picture and say, you see, this is my favorite cup. And then you immediately get a parametric design, and then you can use sliders, or the algorithm say, okay, this is a very boring cup, make it more Bauhaus, make it mid-century. And then somehow the algorithm understands how to turn this cup into a mid-century cup and provides me a suggestion of that design, and so on. And at our university in RWTH Aachen, we actually do a lot of research on that, especially connected with additive manufacturing, 3D printing. As very often, you only can manufacture these new computer-generated designs by additive manufacturing. You may know this famous shoe from Adidas. This was one of the first 3D printed shoes. And the really innovation was not so much the upper, but the outsole, where they used a specific mesh structure to really have a very precise cushioning of the shoe. And the same you can do with industrial applications, what our friends here in Aachen at Fraunhofer ILT and the Chair for Digital Additive Production Technologies by Joachim Schleifenbaum are doing. And they make industrial components where previously this would be a stiff material, but now they say, no, let's produce it with a mesh structure. As this now really allows us to influence the characteristics of these parts in very precise dimensions. As in the conventional processing route of destructive, like milling and so on, we came up with part. If we now produce this part with additive manufacturing, we really can influence every specific part of this part and give it a different material composition, and with this influence the characteristics of the material. So we call it the concept of digital materials as a key enabler of the product design of tomorrow, as we really can digitalize a material and with this influence the characteristics of the material, for example, with regard to stiffness, cushioning, and so on of which actually would be the same material on different parts of one component. And to do this, and it's often behind are exactly these mesh structures, to do this, probably humans are not trained in doing it, and it really gets too complicated. And this is exactly was the second question around this come, who really designs best? Is it the human or the machine? And if, like in this case, it is a machine, well, can you actually grant a patent to a design that was developed by a machine and not a human being? Can you put, can you give a patent to your algorithm? We actually asked this question to the European Patent Office, and they told us, well, probably conceptually it's possible, but we recommend you always put a human also on the patent to be on the safe side. But really a lot of interesting questions derive here. So third pillar, now very, very briefly, was digital design and engineering, really complementing human problem-solving skills with machine intelligence and automation capabilities. And finally, smart product ecosystems. And if you're interested in this, look on the Leadership Network. There's a second webinar from me on Industry 4.0 where I actually go more deeply into this field. But smart products, so it's around really having smart products which are digital, which often lead to digital services and experiences. And we also need platforms to handle the data here. Simple example. If you like cooking, you may know Tasty. It's one of the biggest recipe websites on the world, owned by BuzzFeed, big media company on the internet. Hundreds of millions of followers. And they became successful by having really nice videos explaining you the recipe. However, they realized there still is a gap between being exciting about seeing something, on Facebook or in our book and actually doing it. Meaning they realized a lot of people are watching the recipes but never turn them into food, which is okay for sell advertisement, but not really sustainable for a recipe platform. So they came up with this smart product that actually ended on the 25 best inventions by Time magazine in 2017. And this is an induction, induction cooktop. However, it's a smart induction cooktop that automatically syncs with your smartphone app and will tell you immediately, will analyze, okay, on which stage is my food preparation? What is what I now have to do next? And with these smart products, and you probably know tons of other examples of smart products, and of course, you all have the best in front of you, like your smartphone, the product development process really changed. Think about when they designed my smartphone here. Someone probably used open innovation to, involve customers and suppliers. They probably also really looked in all the app reviews to come up with better hardware features. But then we design it, and normally when we we launch it in usage, we'll think, okay, now innovation is over, and now marketing and sales takes over. However, for a smart connected product, this is where innovation starts. This is exactly where we now have the solution ecosystem, that we get the apps, that we get the services that make sense of the data generated. And it's probably very likely that my most favorite app on my smartphone was not existing when the hardware for the phone was designed. So we really bring nowadays innovation in the usage cycle, which is a very, very different understanding for research and development people, which normally are very happy if they can hand over the product to ramp up in manufacturing and then marketing. And we also learned, and this is a discussion we really had in a hardcore B2B roundtable discussion with German machine tool builders, as they say, if our machine tools, our machinery gets smart, and the business model that is connected about it is very much about the smart services. So it could be the predictive maintenance of the machine, but of course always also the maintenance of the digital twin and shadow. It could be sensor as a service. It could be pay by performance. However, we really realize that how we differentiate in the end are not the smart services, but smart experiences. The way how we really provide to the user, the owner, the decision maker of this machine, that we create additional value with these data services. So also this is a new facet on the development process, how to really design smart experience in a hardcore B2B environment, and all this together, product, service, and experience, these are the components of a digital business model. So, and there are of course many, many other questions around smart product ecosystems, value creation and capture from digital services and experience based on connected products and delivered via open platforms. And the main question nowadays is not so much the value creation, but the value capture. So how you position yourself and your product really in this ecosystem that you capture the value, and then not all the value goes to Facebook, Google, IBM, or Siemens MindSphere. So we're coming to a close. Perhaps you got a little bit an understanding, and I could talk, as I said, a day for on each of these pillars, and we have to go much more in depth to really show the opportunities, but also the pitfalls. But we can see the picture from two perspectives. We can see it like innovation from data. This is our traditional perspective. We say we use digital tools and methodologies for legacy products, and we just enhance the productivity of our research and development process. And this is the traditional thinking. The more information we have, the more we can de-risk innovation. However, you can look on this picture also from the right-hand side. And when we come to what we call innovation as data, actually, we stole this term from Ari Rindfleisch, a marketing colleague in the United States, in Illinois. And he coined this term innovation as data, and I liked it very much, as it really showed us that the data is the source of the innovation. The data is not helping to make the innovation more efficient, but it's really the digital twin, the digital shadows, the simulation models enabled by this, which are really the driver of the innovation process. And however, to do this, we need to embed it in a corresponding innovation culture and mindset. And this now concludes the picture and this webinar. As we know, we can talk a lot about technologies. We can talk a lot about applications. However, in the end, and I truly believe this, there's still human beings involved. So we learned, and was very, very strong a debate in our past master classes on it, that we really need a different kind of development process, not probably so much a stage gate, but more an agile, highly iterative development process to really understand this better. Companies are exploring in startup and business model innovation methodologies to really make sense of the opportunities with regard to the business models coming out of this. Of course, we need new skills with regard to human-machine interaction. We need also digital capabilities in AI and machine learning to explore that. So on top of this, we need this digital innovation paradigm. But before we really invest in this, our very proposition is of this framework where you also have to really understand and be able to strategize and develop really a framework for your company, how digitalization and big data is changing your research and development and engineering function. With this, I'm at the end. I'm looking forward if there are any questions now in this webinar, but I also would be really looking forward to discuss and explore this together, either as a participant in one of the leading intelligent master classes, or also feel free to reach out for me to just a discussion or perhaps a joint research project. So with this, I'm in the end. I give back to Carolina, who will moderate the discussion and also tell you a little bit more how to get involved.
Thank you very much, Frank. I can see that we already have some questions coming in. I just see that it's in German, so please give me 1 second.
Okay.
I don't know, Frank, if you can also see it, but let me just see. Okay, so, it was just a thank you for the great lecture from Hannah. Thank you very much. There is also a question from Sven. Hi, Sven. How do we get all the data from blogs, Facebook, and social media?
Yeah, so actually there are specialized companies that offer you the raw data. And this came up, so actually for the customer insight function, this is quite advanced, as lots of large companies do it for risk management. They try to really screen in real time if there is a so-called shitstorm coming up on social media. So from this risk management function, we really have good tools to crawl the raw data. And then what we did in our project, these are all open source algorithms. And I'm really amazed when you have the raw data, how much you can do with open source algorithms, and you even can self-train into it. I'm a management professor. My PhD students are not computer scientists. But now they do amazing jobs by just looking on YouTube tutorials, perhaps listening to a couple of Coursera courses to learn some basics of advanced analytics and really finding interesting topic models and patterns in this data. But especially for social media data, when you can purchase this or also quite easily write a crawler to crawl this.
Okay, thank you. There is another question from Sven saying, okay, so in the future, companies ask specialized companies. They can't do it themselves.
Yeah, well, as I said, you can do it yourself, but I think as often in most instances, if you did market research in the past, often you also did it not by yourself, but market research was really done by a specialized market research agency. However, what we'll see here is, and there are lots of agencies also here that help you. Not, of course, all of the traditional market research agencies have really the digital skills for doing these more advanced analytics. But and my recommendation would be also, as in some markets, this may be crucial, so you also want to build the capability really in-house. And especially even if you don't do it, on the long run by yourself, you still, if you utilize the data from this, you really want to understand how valid it is. What are the hurdles? As you also know, in traditional market research, you couldn't believe everything the market researcher was telling you. And you could do bad and good market research. And of course, you can do bad and good social media analytics. So I think even if you outsource it, you really need to build some understanding and skills to evaluate what you get.
Okay, great. Thank you very much. Is there any other questions that anyone has? No? Okay, great. I think that's it for the questions part. I just wanted to let everyone know that you will receive a follow-up email with the link where you can go and download the masterclass program for leading intelligent engineering in case you would like to find out more about, really how to reduce costs to market faster and increase that productivity in your own product development process, where Frank and Tim both really guide you through how that looks like for your company and help you develop a roadmap. And for that, we have some spaces still available from the 15th to 17th of May in Gothenburg, Sweden. And that masterclass is run in association with Volvo. So you will get to go behind the scenes at Volvo and really see how that excellence in engineering looks like. So we do encourage you to please go have a look as soon as possible because the spaces really are filling up soon and other masterclasses have already sold out. Other than that, thank you very much for your attendance. Thank you, Frank. And any questions, you can also reach out to Frank on our social media website at theleadershipnetwork.com, where you can connect with Frank directly. But thank you very much, everyone, for coming. And yes, hopefully see you soon. And thank you for attending.